Check in. So we're looking at this school zone sign, and it tells us it has 3 right angles and the other 2 angles are congruent. So obviously those are not the right angles, but these are. Okay. It says find the measure of the other 2 interior angles. How do we do that? Like, what do we need? Let's just break it down into pieces. Yeah, so I would start by writing this interior sum equals 180 times n minus 2. So start with your formula that guides the process. Since it said interior angles, and it's not talking about each interior angle in this case, then we are going to use that first formula we wrote down yesterday. Okay? In terms of this side, we need to write both sides of the equation, always write both sides of a formula. But on that side this time, we're not going to write a given number because we weren't told, but we're going to write all the pieces of information. So 90 plus 90 plus 90 plus 2 unknowns, which is 2x. Okay? And then on the other side, 180 times, and then n is 5 in this case. Okay? And then we just solve this equation. So we get 270 plus 2x, and over here we get 540, and then subtract. Like from here, it's just basic algebra, and we can kind of let go of the geometry for a moment. And we'll get each of those is 135 degrees. I know that this part of the class is called geometry, but you notice there's algebra in it all the time, right? And algebraic reasoning is an extremely powerful form of thinking, reasoning, solving in life, not just in math class, but in life. So if you can translate math to algebra, man, it's good, okay? Like, keep that as a motto for your life as well. Any questions on that one? So it kind of lets us get into these kind that I showed you at the end of class yesterday. They look kind of ugly because there's tons of numbers, and your equations are generally going to be pretty long, but they're not hard to solve, assuming that you write it out correctly. So let's do a quick example. I'm going to start with this one. Is it a regular polygon, first of all? No. Now, it doesn't matter in this case, but it isn't, just so you are seeing these for what they are. Okay. First thing you note, what kind of angles are these? In terms of polygon angle solving, what kind of angles are these? Huh? Yeah, these are interior angles. I suppose it would be probably beneficial if I showed you the other kind, which is exterior. So like those kind, okay? All the red lines are me highlighting the extensions, but the exterior angles of a pentagon in that case. Okay? So clearly these are interior when we compare them to that picture. Are we talking about finding each interior of a regular polygon? No. So in terms of formula, this is interior sum equals 180 times n minus 2. Okay. On the left side, we have all this junk that we have to deal with. So x plus, pick a starting point, and then just go around. So x plus 130 plus 132 plus 130 plus 130. And you could do like a multiplication of these 130s if you want to, but this is also fine. What is n in this case? 7. And now we're back to algebra. We just solved this algebraic equation. And yes, it's a little bit ugly because of all the numbers, but you have calculators to help you. How many degrees does a septagon have? 900. Okay, and then on the other side, we're going to have x plus something, all those things added up. Thank you for doing that. And we'll get x is 112. Okay, so that's an example of how to do these when you're just given some information inside. Occasionally, it will go back and ask you, like let's say that this was, this isn't a good example. Let me show you the next one. Like this one, it says find the measure of each interior angle. And that kind of steers you to think that you should use the each interior formula. Let me remind you what I'm talking about. This one, each interior. But that's not what it's asking in that case, because note, just reminding you that this has to be regular for this one to work. And clearly that one we were just working on, that is, neither of those are regular, okay? So when it says that, it means find x and then plug it in, and then you have each one that you need, okay? So the direction sometimes can be a little confusing. Do you want to do one of these together, or do you feel ready to do them on your own?
When you plug in, can you assume that the angle across from is equal to it?
Well.
Like, is the 2x plus 50, like if the 2x plus 50s were like different equations, but.
Oh, I see what you're saying. So the real question is, can we assume this and this is congruent? This is what you're asking. I wouldn't unless you're told it's regular.
Okay.
Yeah, just be careful with that, because we couldn't necessarily see subtle differences. Like let's say this one was 160 and this was 164 or something. And we wouldn't be able to see that, right? Obviously, if it has the same expression, then we're fine. You could just copy paste all the 2x plus 50s, but otherwise I would check. Yeah. Anyway, thanks for asking that. Feel ready to solve this? Or, okay. Why don't you do this one, just because it's a little shorter. What kind of shape is this? What's it called? Hexagon. So this is interior angles. So interior sum equals 180 times n minus 2. Has anybody memorized how many degrees are in a hexagon? Inside? Yep, 720. Okay, so I see 4 of a similar version of angle and 2 of a similar version of angle. So to shorten this a little, you can just write 4 times 3x plus 20 times 2, or plus 2 times 4x. Saves you a little writing for sure. And then just distribute, combine. Add, divide, x is 40, and then it did go say, the problem went on to say what's the measure of each angle. Again, this is not the each angle formula, but we just take x equals 40 into each of these, and we'll get 3 times 40 minus 20. And I'm just going to write it once, and then on these, 4 times 40 is 160. Okay, how'd that go? How'd it go? Oh, well, actually not.
Oh.
Yeah, it doesn't really get any more complicated. I mean, this one, what would you do? Let's just strategize.
I would add all of them together plus the 90 degrees.
Yeah, so just make sure you catch that this is plus 90. And then what shape is this? Yeah, it's a weird looking pentagon, but it is a pentagon. Okay? So it would be all that stuff added up and then set equal to 540. Everybody good on that? Okay, let's talk about exterior angles then. First of all, the exterior, listen. Exterior angles are just angles formed when we extend a side. So I just extended that side. We're talking about that angle there. Okay? So extending one of the side lengths makes an exterior angle. And tell me about, let's just zoom in on this one. This is a hexagon. It is a regular hexagon. So 720 divided by 6. So each of these are 120 degrees. Okay? Everybody follow what I just said? I said it kind of fast. Regular hexagon is, it's a regular hexagon. It's not, and then that's 6 sides. So that is 720 degrees. Because it's regular, each interior angle, I'm just using that second formula that we wrote. We just divide by 6. So each interior is 120 degrees. That's what I said. Okay. How many degrees is this exterior angle?
60.
Okay. How many degrees is this one? 60. This one? 60. Okay. And one more. So how many degrees are there total in the exterior angles of this hexagon? Six times 60, right? Okay, let's do this shape. This is a regular, what? Octagon. Okay. So how many degrees are in an octagon? In any octagon.
8.
How many degrees?
Oh, my bad.
Total interior is 1080 each. Go ahead and divide that by 8, please. Okay, don't miss this.
135.
Okay, how many degrees are in that exterior angle? Okay, how many degrees are going to be in every one of these? What is 45 times 8?
360.
Interesting, right?
So they're also.
Totally different shape. The total exterior is still 360. Okay? How about pentagon? Let's just do it real quick. What's the measure of each interior of a pentagon? 540 divided by 5. What's the exterior angle? What's 72 times 5?
360.
Okay, what are you noticing? Do you think it depends on the shape? Do you think it depends if it looks funny like this one?
No. Well, that one's.
No. Okay, so this is nice. Go back to your formulas wherever you're collecting those. Sorry. And we're going to switch to exterior now. total exterior is always 360. It does not matter if it's regular. It doesn't matter what shape it is. It's just 360. Yeah.
If you know it's like congruent, can't you just divide 360 by the number of sides?
Yeah, let's write that down. That's if it's regular, then yes, you just divide by the sides. Before we do that, let's remind you, like, just sketch some hexagon. And remind yourself what an exterior angle is. So extend aside, the exterior angles are always going to add up to 360. You guys took the total there implies a sum, right? So maybe total exterior sum, if you want to make sure you're clear on that. We said interior angle sum, so let's say total exterior sum. Now, Tim just brought this up, so we might as well write it. Each exterior is what? 360 what? Divided by n. Now, what is that only true for? And what is n? Okay. So basically what this should tell you is that exterior angles are easier. Hopefully that's what you see there. I'm going to give you a little bit of time to practice this, and then I want to move into our first quadrilateral. So by the way, this concludes what we are going to do with all polygons. From here on out in the unit, we focus specifically on quadrilaterals, okay? And we do dive very deep into that, like you saw, but excuse me. Do we need to do an example of exterior, or do you feel like you're probably got this? I mean, I'll show you one if you would like, perhaps. Here's one. So notice it says, what is the measure of each exterior? But is that a regular? No, so you're not using the each exterior regular formula, right? You are following all of this stuff and solving for it. Do you want to try this one while I hand you out something? Okay. Okay, it says suppose angle 1 and 3 are congruent. Again, put information in pictures, it's helpful. It says angle 1 is 3x, so that means angle 3 is 3x. Also, angle 2 is 2x. I'm just going to make that 2x. Sorry. There you go. Congruence, 3x, 3x, 2x. It says what's the measure of each exterior angle. I would note that this is a linear pair here for 5, which is 90. And same with 4. So we're going to write our formula, write it down first. Total exterior equals 360. And then we just make a sum over here. 3x, 3x, 2x. Okay? And then we just solve that. 180 plus 8x. What's 180 divided by 8? So x is 22.5, and then plug that back in for each of the angles. All right, so that's kind of just a version of exterior angles. Any questions on it? Here's another one. I don't want you to do it. It's the same idea though. Just go around and make sure they add up to 360. Yeah. Let's talk about one of these kinds. The measure of an exterior angle of a what? Regular. That's huge. So this is the exterior angle. Find the number of sides. You can maybe do this in your head. How many sides does this one have? If each exterior angle is 30 degrees. Each exterior is 360 over n. Where do I substitute 30? Seriously, what? There we go. Each exterior is 30. How do you solve this? Yep. So 30n equals 360, or n equals 12. Okay? It's just use your formulas. It makes this so much easier. Let's do a quick review of this kind. It says the sum of the measure of the interior angles. What is not shown? Actually, you know what? Never mind. It doesn't need to be. Which formula is this? Let me ask you that. We now have 4, so let's just say 1, 2, 3, or 4. Everybody hold it up. Which formula are you going to use? Yeah, so this is interior sum equals 6120. I'm sorry. Equals 180 times n minus 2. Solve for n. So on your paper, can I borrow one? I put it away. We're not going to do very many of these. We're going to work maybe 15 minutes or so. I'm going to get through one. Okay, circle number 6. Circle 8, 10.
Say it again. 6,
6, 8, 10 is all that says so far. 15. 6, 8, 10, 15. That's 4 problems, so about 15 minutes is plenty of time. Maybe a little less than 15.
Maybe.
We leave at 10:15. Yeah. So let's stop at 10 o'clock. You need more practice. Just get on Google this weekend and do some more of those problems on that paper. Okay. In terms of answers for that. Number 6 is a regular hexagon, and we're talking about exterior angles. So just divide by 6 and you get 60 degrees. Number 8 is the interior sum formula. We know the total. We're solving for n. So plug in 50, 40 for the interior sum. And then you get 26 for n. It should be 30, shouldn't it? It should be 30. Number 10. Now we're talking about each interior. So that you do have to read those context clues. Each interior, and it says regular. That points you to equation 2. So plug in what you know, which is 5. A pentagon has 5 sides, and then you get 108. And then on the back, number 15. A septagon or heptagon is 7 sides. So all those things add up to 900, and then just subtract to get x. Yeah.
For number 8, it's 28 seconds. Because 28 times 180 is 5
Oh,
seconds.
it's 30.
It's 30.
Because you have to
Yeah.
do it minus 2, so then you just add the 2 back.
I look at what I did. This is bonehead right here. I wrote add and somehow did subtract. So you guys, we all do that sometimes. Some of us more than others. All right. Give me a fist of 5 on your confidence level with polygon angles, please. Kenzie. All right, we are ready to roll. So your first quadrilateral. Everybody listen, please. Like I said, the rest of the unit will be focused on quadrilaterals and kind of back into properties, driving equations of side lengths and angles. That's basically what we're going to do. Did you know that a kite is a geometric shape? Did you know that? Oh, well, good point. Aren't you supposed to be a teacher? All right, diagonals, this word. We'll get into your notes here in a second, but I just want to set some background vocab. So diagonals are lines that connect vertex points, but not together to make side lengths. Here's a diagonal. So AC is a diagonal, and DB is a diagonal. So we're connecting across the figure, okay? So in this kite, all kites, let me fix that one. All kites have similar properties with their diagonals. Do you think you can come up with some just by looking at what might be true? Just take a guess, and there's a good chance your guesses will be right. Well, that's just because they intersect, but not specifically because it's a kite. Yes, they do, so keep that in mind. So I'm looking for things about their lengths or their angles. Like, what do you think is true? What do you think the measure of these angles are here?
90.
Yep, so these are all 90. They are perpendicular. Okay, so that's what we're going to write these, but just I want you to see that some of these properties make sense. It just looks to be true. So all of those angles are 90. What do you think the long diagonal does to the short one? Yeah, awesome. So these two pieces are congruent. So the long diagonal bisects the short. Do you think the short bisects the long?
Yeah.
In other words, could I do this? No. And we can make that even more obvious if we draw like a really long, skinny kite. And just picture, like, there's no way that's bisected, right? So I'll give you this little piece of advice. If you ever get stuck on properties, sometimes it helps to draw an exaggerated version of the shape. So I just drew an exaggerated kite, and it made it super clear that the long diagonal is not bisected, not even close. Okay. Tell me, I think you're going to keep getting these. What do you think is true about these angles right here? Those two that I circled.
You only circled one.
I did not.
Oh, they're congruent.
I circled 2, yeah. So that long diagonal doesn't bisect the short diagonal, but it does bisect these angles. Okay? Everybody see why? Like, does it look like it does that?
Yeah.
Okay, there's one more maybe not obvious property. which is, what do you think is true about angles, total angles A and C? They are not bisected, but they are congruent to each other. Okay? And then last thing is these sides are congruent and these sides are congruent. So I think if you just look at a kite and start saying, hey, what seems to be true, your gut will steer you in this case pretty well. Okay? But yeah, it's the name of the shape. With all these properties, that means lots of different kinds of solving. Okay? We could solve with the Pythagorean theorem because it has right angles. We could solve by using bisectors. We could, like, if you note, this is what kind of triangle? Well, both of them are, technically. Isosceles. They're both isosceles triangles. So we have isosceles triangle solving. Okay? Lots going on in just a simple little shape called a kite. So on your paper that I handed you, I'm going to get sick of scrolling that, I think.
Why don't we just make it so your screen's blinking out?
I don't know. I'll probably need to do that. Guys, the copy is not super great, so make sure that all this stuff stands out. Most of this is already marked on your figure. So we have two sets of congruent sides. We call those consecutive sides. Okay? The diagonals, you know what? Let's start writing it down. We're going to make a list. All of it's in the figure, but let's make a list. Diagonals are perpendicular. Long diagonal bisects short diagonal. The long diagonal, you sick of that word yet? What else does it bisect? It bisects the angles too, okay? The short diagonal angles are congruent. In the picture, that's A and B. Let's see, that's pretty much covers it, I think. Are these, I don't know what letters these are, so just look up here. Are these angles congruent to those angles? Like these are both these are congruent because it's bisected, but are those two at the bottom congruent to these two at the top? Could I copy the blue tick marks over there? No. Okay, again, let's do the exaggerated version. If we have like a kite that's like this, do those split in half look like these split in half? Like not even close, right? So that exaggerated strategy is really helpful. So these need 3 tick marks. It's a busy figure. I'm just double checking that we haven't forgot any of them. Oh, well, let's define what a kite is. Kind of. Yeah. Piece of material tied to a string. Flying in the air. Okay, this has 2 sets of consecutive congruent sides. Okay. I'm gonna just change my color. Your notation is fine, but I wanted to match that statement. And one other thing. Thinking back to last unit that we just tested on, do you see congruent triangles all over the place? By like side, side, side. HL, SS, SAS, like there's tons of congruent triangles. So it's sometimes helpful to remember that when you're solving with these. Just gonna write a reminder. Lots of congruent triangles. All of these things allow us to solve. Again, because of the right angle, if you want this as a reference here, it might be helpful. You will use the Pythagorean theorem with kites. So you could put a reference to that right here. What is the Pythagorean theorem? All right. 2 days with no homework. What the heck is going on here?